Hey everybody, this is Dan from Abbott University, and today I want to go over a particular kind of calculus problem that you might have to face in calculus class. And these are the problems that have to do with particles moving along the x-axis. Alright, so usually with these kinds of problems, it's going to be something like this where they'll say a particle moves along the x-axis so that at time t its position is given by this following function. And I think it's important, first of all, to just get really clear about what do they mean by that? Well, basically, you've got this x-axis, all right, and obviously the x-axis has, values on it, like that. So this is stuff that you should all be pretty familiar with. And there's this particle that's literally just going like that, all right? And depending on how much time goes by, the particle is in a different position. So, for example, at 3 seconds, maybe the particle is here, and then it keeps going this way, and then at 4 seconds, the particle is here, or whatever. But this function basically lets you know where the particle is at any given moment in time. Okay? So that's what this function is about. Now, when you're dealing with these kinds of problems, you're going to probably have a list of questions that are testing your ability to do derivatives and apply derivatives and so forth. I'm going to assume that most of the people who are watching this video already pretty much know how to do basic derivatives, because that definitely will be coming in handy. But anyway, I have a list of questions over here that I'm kind of shuffling over here. We're going to go through each one by one. Okay, so these are the kinds of questions that you might have to face if you're given this scenario. First question is, at t equals 0, is the particle moving to the right or to the left? And then explain. Okay. So the thing about this original function is this is a function that lets you know the position of the particle at any given moment in time. This, however, is asking about the direction that the particle is moving. It's asking whether the particle is moving right or the particle is moving left. Now, when you're dealing with an issue or a question of directionality, that's where we're going to want to pay attention to the velocity of the particle. Okay, now velocity is a word that means really two things. Velocity means, I'll just call it velocity, my handwriting's kind of bad, means not only speed, so velocity can tell you about how fast the particle is moving, but it also tells you which direction it's moving. Okay, so that's very important to know. So therefore, if we want to know whether it's moving right or left, well, we're going to want to pay attention to the velocity. Okay. Now, how does one find the velocity of this particular particle? What you can do to find the velocity is you take the first derivative of the original function. Now, I'm going to assume that, again, everyone knows how to do that. It basically would be to apply the power rule. And it would look like this. If you were to do the derivative, it would be x prime t, and that equals 3t squared minus 12t plus 9. Okay, so that's to use the power rule, and that is the derivative of the original function. Now, this derivative can tell you what the velocity is at any given moment in time, and it also tells you, and by that it means that it can give you the speed and the direction at any given moment in time. So basically, the way that this works is probably what your teacher will do is the teacher will have you draw a number line and get clear on what the critical values of this function is. And the critical values are found by setting this function equal to 0 and then solving for t. Okay, so basically if we want to know whether the particle is moving to the right or to the left, the first thing you want to do is find the critical values. So by setting this equal to 0 and then solving, we could factor out this 3. And then you could immediately divide both sides by 3, actually. And then you would get 0 equals t squared minus 4t plus 3. Okay, because by dividing both sides by 3, well, this divided by 3 cancels the 3 out. 0 divided by 3 is just 0, so it remains 0 over here. And then as a final move, we could kind of factor this so that it looks like that. Okay. So what this means, after the factorization, you would realize that t really has two values, t equals 1 and t equals 3. So what does that mean for us? What that means for us is that the graph of this derivative function crosses the x-axis at those two critical value points. So what I would do is I would plot those points. Okay. Now, I happen to know, and you might know this already, that 3t squared minus 12t plus 9, that's a parabola, and in fact it's an upward-facing parabola. Okay. However, I'm going to assume that you're somewhat rusty on your ability to recognize and graph parabolas, and we're just going to kind of use this method pretty much for everything, because occasionally the derivative won't be a parabola. Occasionally the derivative might be a more complicated function, and in that case you're just going to want to do what we're doing now, which is to set it equal to 0, find the critical values, plot the critical values, and then you're going to do this other step that I'm about to do right now, and that is to test values in the intervals. So basically you have an interval of everything to the left of the critical value of 1. You have an interval where we could analyze t values between 1 and 3, and then you have an interval where you have from 3 on. Okay, and what you could do is you could take test numbers, like for example we could test the value 0 here, plug it back into this equation, and find out what the function would equal as a result of substituting 0 in. And really all you're concerned with is whether it's positive or negative. It actually doesn't really matter what the number is. We're only concerning ourselves with whether it's positive or negative. So let's say that as a test value, we decide to test 0. Well, that would result in the following. So x prime 0 equals 3 times 0 squared minus 12 times 0 plus 9. And after all the calculation, you would realize that it is 9. Now 9 is a positive number. Okay, so 9 is a positive number. Right here, I apologize for that. 9 is a positive number. And what that means is we could write a plus symbol in that interval, because we tested a value in that interval and we realized that it pumps out a positive number. So that's that. Now we could try the interval between 1 and 3. I think, as most of y'all would probably guess, we'd want to work with 2. So trying x prime 2, that would end up being 3 times 2 squared minus 12 times 2 plus 9. And if you were to do all of that calculating, you would realize that that is 2 squared is 4, so we're dealing with a 12 here. 12 minus this would be a 24, so it would be 12 minus 24, that's a negative 12. And I already can see, I'm not even going to worry about it. It's negative 12 plus 9, that's just going to give us a negative number. I mean, we can worry about it, I guess. So negative 12 plus 9, that's a negative 3. So anyway, we have a negative here. Okay, so that's that. Now let's try a test value for this interval right here. And I'd say 4 is a decent value to test in that case. So let's try that. So if we're going to do x prime 4, that would end up being 3 times 4 squared minus 12 times 4 plus 9. And this would be 3 times 16, which is 30 plus 18, which is 48. and then we'd have 48 here, and then we would have plus 9. So these, of course, would cancel, and you'd be left with 9, which is a positive number. So I'm just going to concern myself only with whether it's positive or negative. Okay, so that is how you work with the test values. And so here we have a plus here, a negative here, and a plus here. So what that basically means for us is, I might not know much about this graph, but I know that it's positive in this region. Once it hits the critical value, then it's negative, and then once it hits this critical value, it's positive again. Okay? So what does that mean for us? Well, when it comes to the velocity function, which is the first derivative of the original function, when it comes to the velocity function, you can tell a lot about the behavior of this particle by analyzing the velocity function and having this general idea of its graph. Anytime that the graph of the velocity function is positive, that means that the particle is moving to the right. Anytime that the graph of the velocity function is negative, that means that the particle is moving to the left. So basically, at t equals 0, is the particle moving to the right or to the left? And explain. Well, 0 is over here, and there is a plus sign associated with it. So therefore, the particle is moving to the right. Okay, so the answer to that is it's moving to the right. And how would I explain it? Well, I would probably say something along the lines of how the graph of the velocity function at t equals 0 is positive, and therefore the particle is moving to the right, because a positive graph in the velocity function means that the particle is moving to the right. That's really all there is to it. I'm pretty sure your teacher would accept that. All right. So anyway, that's how you do the first question of, is the particle moving to the right or to the left? Okay, so I'm just going to pause the video here and stay tuned for the next video where I explain yet another kind of problem that you could face.